And so where we can do that is it's in the forum. So I'm going to share my screen and let's see. So I'll get started in general, and then I'll share my screen and answer questions. So I'll monitor the chat window. So thank you, Monica. I'll answer that question in a moment. And then also, you know, jump in. I expect this to be a smaller, kind of more intimate group. So if you have questions, go ahead and unmute yourself and interrupt me. And the objective today is to go over both of the earth science modules, and they are, one of them is a hydrology unit called Water as a Shared Resource, and the other one is a climate change one with greenhouse gases. And so, yeah, if you have any questions, post them in the chat or just interrupt me, like I said. So I'm going to go ahead and share my screen so that we can, I can walk through some of the items. Okay, so to answer the question about the sharing a portfolio, so I am on our online course, the MOOC, and I went to Forum, and this is it's a Google group that's kind of hosted inside of our forum here on the course. And if you scroll down to here, you can see that there are some topics, and we've been monitoring them and trying to answer questions. And this is where you can share your portfolio. So you can click on that and share it to that space. And this is the portfolio. The reason why we're doing the portfolio the way that we are is it's allowing us to verify your participation. Since, to be honest, the platform that we're using called Course Builder, it doesn't have all the functionality that we would like. So the portfolio allows us to see that you've been keeping up with the different parts of the course, and that it also is a way for you to curate resources that you can use in the future. So it has sort of a dual purpose in that case, but the portfolio is what we'll look at to gauge how far you've progressed and to honor certificates of participation. And if you have any questions on that, you can certainly post questions in the forum, and we'll get to those. Or tonight, we can try and answer those as well through the chat. Okay, I just want to check. Nope. All right. So I'd like to go over the general aspects. One thing, another issue I wanted to address was make sure we have been looking at the portfolios, and what we're noticing is that some people are using Google Docs, and they're doing a great job of, you know, putting some information into their portfolio. And since the portfolio is a Google site, it interacts very nicely with all the Google products. But if you're going to use a Google Doc, you also have to make sure that it's shared. And so that is this blue box up here, share. We want to make sure that we click it and that it's viewable, so we can get that. We're going to make it viewable to anybody. So if the link is embedded, anyone can view. The default is that it is only for yourself. It's private until you share it out. And if you are working with one of your school Gmail accounts, if you guys are Google Apps for Education School, your permissions are probably even going to look different than that. So just make sure that it's viewable to anybody outside of your school if you're a Google Apps for Education School. All right, so I want to get started with some things. So I want to hit the shared water resources first, and then do the climate change one. But all of the modules are set up. These are the content area modules, so that is the Earth, Life, and Physical Science. They all have a similar structure to them. which is that the lesson one, there are 5 lessons, and the lesson one is more about engagement. And so we can, actually, I'm just going to copy this over onto my Google Doc, and I'm sharing a white screen, but now there's some text on there. So they have an engaging activity that kind of hooks the kids in. It's foundational to some understanding. Not always all the background knowledge that's needed, but it is a good area that kind of hooks into discussions throughout the unit or module. Lesson 2 is going to be decoding the base model. So we have base models that are usable for your students, and so they don't have to build this from scratch. They are just kind of looking at something that already exists, and then they're decoding it, and they're learning how to verbalize that. And then they will make minor modifications, maybe adding a slider or adding, in the water resources one, they're adding a pump. And lesson 3 is further modification of that base model. The lesson 4 has experimentation that they start with. So that is, they have the data collection, the instrumentation is what we call it, with the data boxes and graphs. And then after that is the analysis. So module 1 has a very unique structure because it's introductory and foundational, but our other content area modules have all of the sort of a similar structure for this. And this is all delineated in what's called a pacing guide, so I'd like to show you what that looks like to make sure. So this is what our curriculum looks like, and this is the Module 2 Earth Science one that is water as a shared resource. So we have an overview, and then there is this pacing guide that's available. And it's just a basic summary of what you as a teacher or somebody that's teaching somebody else about this module. It's kind of a quick and dirty look at what's happening on each lesson. And so for the water as a shared resource, we encourage using these videos that are kind of engaging. One of them is Jay-Z, and I know you're like, what? But he actually does a great job. He is the water ambassador for the UN, and he's in Africa, and the kids just love seeing him because he's just very honest about how he didn't realize that how big of an issue water was in that region, and it has a nice discussion. There are also some other videos that you might be interested in that are just kind of hydrology, the water cycle videos, and that's in our YouTube playlist. So I'm on we have our own website outside of the course, and this has some resources that you might be interested in. It's projectguts.org, and these are the videos. We have a playlist for Module 2. And so this is the Jay-Z one. And then there's also some background ones, the water cycle and the water and you. But those are the kind of engaging ones. But then we have a further activity that is called Some for All. I forget the name of it. Here we go. It's a behavioral economics type of experience for students, and it gets them to think about what it means. Here it is. Some for all for one. And this activity is based on, as I said, behavioral economics, and kind of if you have a finite resource like water, how do you engage a community in effective decision making? And so it starts off with an experience that allows kids to kind of be greedy. They don't even know that they're going to be greedy, but they end up invariably being greedy. And then there's like 2 different rounds. And then the third round allows for discussions and things like that. I'm going to check the chat real quick. Oh, yeah, I can show you that in a moment. I'll show you how to get to the videos and everything. So that is the lesson 1 for water as a shared resource. And that just allows students that haven't really thought about where their water comes from to think about that in a deeper way. And the water, the base model is basically a water pumping base model, and it's a hydrology, it's based on hydrology. So let me go through, we have a gallery that is specific to our, so this is, I'm in Star Logo Nova, and these are our galleries for GUTS. So you have slnova.org, and then you could get rid of that. And this is all of our galleries that are public. And so we have modules, we have, the galleries for all the modules plus a few other things. And the module 2 water resources are here, and so these are the different ones. There is the base model, it says starter in capital letters, and then there are these other 5 other models that are sort of modifications, and we've kind of given you some ideas already. Those are really meant for you as a teacher, not necessarily for the students themselves. However, the one for students is this base model. And we'll load that up. And this is the one that they're going to remix into their own gallery and make some modifications. And so this is what it looks like. We have the sky, we have the earth, and we have the pump that's indicated by red with a yellow wellhead there. And so the water moves through the water cycle essentially and has some interesting behaviors that they look at and they learn to decode. Now, in this lesson, we use what's called the model observation form, and that is for the students to just kind of observe, right? What do we see happening? So they don't even have to look at the code necessarily. Just what do you observe? Well, I see blue dots falling. They're going from the top to the bottom. I see that when they move at a different speed in the blue versus the brown, they stack up, but then they are lower near the well. And so these are the observations that students can talk about, and maybe they could observe even that the blue spheres get smaller. So that allows us to just kind of engage in that. And so the model observation form is just that very basic, what do you notice? It can be done individually or with pairs, or it can be done if you have like a screen project, like a Promethean board or something. It can be done as a whole class, which is very effective. So then what they're going to do in lesson 2 is, beyond observing it, then they're going to, let me remix this into, oh, I'm not logged in. Sorry about that. So what they do with this one is that they, where's my, up here. So when they get to the space model and they observe it, then they can jump on computers and do the driver navigator pair programming, and they're going to remix it. And the first thing that they do is add a second pump to it. And the way that you'll do that, there is a video that walks you through this, but basically in the world is the setup, and you can see that there is the make pump procedure that is called here in the setup, and you would just make the students would make a second pump that is with a different X and Y. And if you want to get fancy, you could make it a different depth. So instead of 49 times, it could be less than that. So that would finish up lesson 2. And this is presuming that they've already done lesson 1, so that they have a foundation of Star Logo Nova. This isn't the first time that they see it. And so they actually go quite quickly through this to figure that out. After that is the, so that's lesson 2. Lesson 3 moves us into, we have some information here in our module for water as a shared resource to talk about the math that's in the Star Logo Nova, sort of the Cartesian planes, the quadrants, and the X and Y coordinates, and then also heading as it relates to a protractor. So that's the decoding, and essentially you could assign each of these to pairs of students to explain verbally to each other. This is the teacher cheat sheet here with the information. So now this is the model observation form that I mentioned that students think about. And we ask them to think about who are the agents. So in that case, it would be those blue spheres. The environment sort of has a blue and a brown area. And then the interactions, and they'd have to study that a little bit more. But there's interactions that they can visualize that are like that they're falling, that they move away from each other in the ground. And an observation would be they get smaller. They might not know why they get smaller. So the next lesson is in lesson 2 is to add a slider for evaporation rate. So they are in this. So there is already a procedure where evaporation is happening, but it's happening at a static rate. So let me get that in a better visual. So it has a 5% chance that it's going to get smaller or evaporate. And so instead of a 5 here, we would have a slider value, and they could change that. If it's 100%, it goes away completely down to 0. And after that is they're going to start to think about what they're going to do with the model in general. And they're going to start to, after they've added the water pump, they're going to start to run experiments. And they're going to do that using one of our forms. They're going to use the experimental design form. And these are suggested sort of paths to have students think about computer models and to think about how they can use a model to get data from. And they think about sort of what they're changing. So it could be as simple as just the evaporation rate. It could be the number of wells. It could be the depth of the wells, et cetera. And what's important here is to start thinking about the values that they would have, the sliders, et cetera. And we also have the model design forms. This is where they're starting to think about, in general, like even, if they wanted to go completely off and make their own project, they could use the model design form, where they start to think in a larger picture of what they're trying to model. The model design form has a lot. There will be some more skills involved with that. So lesson 4 is the time to basically continue customizing. We've had students do asphalt layers. We have in our, oops, that's the wrong one. in the gallery, we have a couple of them that we were suggesting that would fit nicely with earth science, which is different substrates. So if there's a clay, sand, or gravel layer, what would that do? And we have them vertically, and they look like ice cream. But if you notice, I loaded this, and there are no widgets. There's no setup or forever. And you might think that that's going to cause a problem, but I can just grab an edge of my browser. And when I do that, I can bring it in, and all of those widgets come up. And this is because I'm working on a smaller screen, and the graph was kind of on the side. So we have the, this is just a setup suggested one for you all that already has evaporation, a slider and everything. And you can see that there are vertical layers, so it's just a suggestion as to what could be done and how it could be done. And you can use colors to represent the different layers, and they can move at different speeds through those layers. So let's get that up. Again, the graph caused those widgets to disappear, but now they're back. And when looking down, so in the world, you can see there's sand, clay, and gravel, and they follow procedures that are similar to the original Make Sky and Make Earth. They're just slightly different headings and colors. And then when we have in the turtle page, when they're moving, they are checking their colors, and they're moving at different rates through the different colors. And so that would be, students, this is how you could code something like that, where they're checking the terrain. Now, one word of caution is that currently not all colors are created equally, which makes it limited what colors the turtles will react to. And so we definitely know that they react to cyan and brown and yellow, but they also react to white, black, magenta, and lime, and a few other colors, but they don't react, for instance, to orange. I know that. So if you're not getting them reacting to something, it's not because you're coding it wrong, it's because of the color. There's a few of them that don't work in expected ways. And so we're finishing up with lesson 4. Students are getting into their model and making some interesting hypotheses about their model and how it works. And then the last part is for students to get into the project design form. And this is the one that also requires them to think deeply about their model and what they're trying to, what abstractions they're bringing into it, and what are they trying to model in general, and what assumptions they have in their model. And so the last lesson is for them to basically run experiments and collect data. And then also we recommend that there's time built in to share out to their public, to the other students, if possible. So that's, in a nutshell, the water is a shared resource. I do know that somebody asked me, how did I get to the videos? And there are a couple ways to do that. You could search in YouTube for Project Guts. We have our own YouTube channel that all these videos are hosted on. So that project's not going to work very well. So Project Guts, Growing Up Thinking Scientifically, if you click on that, that's our YouTube channel, and you know you're in the right place if you see this flash. And we do have playlists for each of our modules, and so Module 2, Water as a Shared Resource, has its own playlist, and that has all these videos here for you all to watch, and they are, they just go along, and the audience for these is teachers, but you're welcome to use them however. The other way that I got there, excuse me, was to, on our webpage, projects.org, we have a resources tab, and this is meant for resources relating to our computer science and science curriculum. And so Module 2, Water is a Shared Resource, we have the teacher videos for Module 2, and so that takes you to that same area. I'm going to pause now and see if there are any questions or if there's anything that I should talk about or cover. All right, well, thanks for sticking with me so far. So now what we're going to do is jump into the climate change one. So we actually created 2 Earth Science modules. We'd love to have more, but funding and time are one of our limitations. But so the hydrology one is the one that is linked and is more obvious in the code.org curriculum. And it's what, if you're joining us to become a CS and science facilitator, New Orleans, et cetera, we use the Water as a Shared Resource curriculum. However, there is an option for what is known as the climate change one, and that is prominently, you can choose that through our Project online course, our MOOC, and so we have the 2A and the 2B. 2A, sorry, 2A is the greenhouse gases, and 2B is the water as a shared resource. So, and all of this curriculum, so basically to create this course, we kind of chunked the curriculum into different sort of quantities for the lesson 1, lesson 2, lesson 2, 3, etc. But I'm using a PDF here of the greenhouse gases and climate change that has all of it together. And basically, this is having students think about modeling the gases that contribute to climate change. And the lesson 1, the engaging activity here, is actually online. Most of our engaging activities are not necessarily online, but this one is, and this is where they are calculating their carbon footprint. And so this is from the EPA. This is not us that created it. And it basically allows for a discussion about the fact that energy use, when you turn on a light switch, where is ultimately that electricity coming from? And in the U.S., the majority of our electricity is from fossil fuels, so there is carbon that is being released. Now, I know that that's not true for certain regions, or even kids have houses that are with solar panels and things like that. And so that's a very rich discussion, but the majority of the time, fossil fuels are being released for that energy. And so it's a carbon footprint that they're calculating. And what's nice about this web page is that it has all of the, it has all of this just very nicely kind of laid out, and it does the calculations. Here. I might have clicked on the wrong thing, but so calculate your emissions. There you go. So this is the calculator, and it just has questions, and they answer them, and it basically will let them go through and ask questions, and it'll calculate the carbon dioxide for them. And it does show you how they're calculating it. So it doesn't have to be hidden, because you can find out more. So that's the engaging activity that gets them thinking about their, just the carbon, where's carbon coming from in general. And there's a great foundational video that we recommend that has the images about the greenhouse gases, and does a nice job talking about the sunlight and everything. Did I not share my screen? Wait. I apologize. I'm supposed to be sharing my screen. Okay. So let me go back to what I was doing very quickly. So with the climate change module, we were looking at the EPA website that has all the calculations, and so that's what that looks like. Kids are very successful with it, and I find it leads to very nice discussions in general. So then we have the video that I was talking about. After they calculate it, then they can jump into, the video is just foundational. It's optional, but I think it's one of the best ones out there for explaining greenhouse gases and how that works. So then lesson 2 jumps us into previewing the greenhouse gas model, and this is a fun one because it's 3D. And so I'm in our gallery with the CS and Science greenhouse gases, and I look for the word greenhouse gas-based model. And I'm going to go ahead and remix it right away. All right, so then we have, so when I hit setup, it automatically goes into 3D. I don't know if you've explored this option yet, but most of the models that we've been building have been in 2D, but in fact they have a 3D capability. And you can use a block called Take Camera to do that, or you can do it by using your mouse and the Alt key. So that's, we have the world, we have the sun, and we have radiation. We have graphs that collecting information about the heat. You can see it really is fun to look at with the radiation coming down, and then you have the infrared, the heat being transmitted back or being absorbed. So what that looks like is we have the Take Camera. We have an invisible agent that we've placed and has the 3D view, and we are we just have the sun initially, and then the sun is hatching solar energy that comes out as a small yellow sphere, and so it goes through. And so the kids would, in lesson 2, would decode this. They would take a look at all of these procedures and discuss what's happening with them and talk about that and explain it to each other. After they decode, they're going to make some minor modifications. And so now one of the things that I like about this module is that it really ties very closely into this idea of computer models. Everyone is hearing about computer modeling of climate change, and some of them are mathematical models, but in this case we're doing an agent-based model, but it has a rich discussion there. So this is the decoding part, and then they will also do the model observation form and what is happening in the world, and kind of thinking about what are the abstractions, what are they seeing happening. And then they decode that. Sorry, I'm scrolling through quickly. I wanted to get to our day, our lesson 3. Okay. So lesson 3 is they are going to add carbon dioxide to this, and so this is the current model does not have carbon dioxide, it just has the solar radiation that's happening and the heat and things like that. And so now we're going to look at some agent that's going to release the carbon dioxide into the atmosphere, and then these the reflected energy is going to interact with the carbon dioxide to have to potentially increase the heat or change some aspects there. So they are going to add carbon dioxide, and they're going to, so it's a new breed, and they will then add a factory that is going to emit carbon dioxide into the atmosphere, and they're going to start to run some experiments with that. So we have an example of that. Let me go back to that one. I'm going to get back to our gallery. Lots of window resizings and things. So this is we have a model here with a simple factory in carbon dioxide. Again, this would be for you as a teacher to use and kind of get like, oh, that's how you do it, or refresh your memory. Or if a student is absent one day, you could have them just remix this one so they're not so far behind. Remember, resize if you don't see the widget. Okay, so we're going to set up, we're going to hide our graph with this button here. We have forever, and we can do the Alt key and get our 3D model, 3D view. So I'm using Alt here instead of the take camera. And now we're going to run the factory, and you can see that there are these little gray pyramids that are coming out, and we can how much carbon dioxide is emitted at each of the ticks there. We can increase that, and we can also increase the amount of time that the factory runs. So I just did a huge amount, and so it's probably going to freeze up a little bit. But that is the carbon dioxide that's coming out. And I can show the graphs here, and we can see that the carbon dioxide levels have come up, and then we also have some heat that's changing as well. And I apologize, but I can't get to that other graph right now. So this is a fun one. Kids love to see the carbon dioxide. However, I do caution that you keep the agents under a certain value, or else they will freeze up the computer. It'll start to go really slow, and you can kind of see that happening here. I would, it depends on the processor speed of your computer, but I would keep things under about 3,000 agents in general. So we just did the, oops, that's the water pump, I can close that. We just added the factory that's emitting carbon dioxide, and we start to run experiments using the experimental design form and go through that. We also have the model design form, so this is where we're transitioning into the experimental phase of the computer modeling. And lesson 4 is basically that they are using, they start to customize even more their greenhouse gas model, and will then lead to collecting data and analyzing it. And so we have a suggested form for that, which is the experimental design form. and so they're leading towards the experiments and what data they're going to collect. And then the project design form, they look very similar, but the project design form is more robust, and it is just kind of getting them through the deeper questions that they have to answer. And if they can answer these either in a written format or present them verbally to you, then they've really mastered a lot here. They've mastered the ideas of climate change and greenhouse gases. They've mastered how to create a computer model of it, and lots of, and the fact that data is coming out and how you would analyze that data. So those are some rich experiences there. So those are the two Earth Science modules. So I don't have anything much more to say about that. But again, these are choices for you all to explore in our curriculum. And oh, there are some customizations. Let me go through that. Let's see. Going back to our gallery of the greenhouse gases, there are some cars that are moving. We have the albedo effect, so adding the absorption or reflection of energy, solar energy, is a great one to go through. And we can have increased the albedo or decrease it, and they can take a look at that. All right, so at this time, I'm going to stop sharing my screen and see if there are any questions or any comments, or if there's anything that I can help you with in general, and it doesn't have to be about Earth science. All right. Well, it's 45 minutes into the MOOC, or the webinar, sorry. But I just really thank you for your time and hanging in there with us. Thanks, Amanda, for letting me know. And just wanted to see, you know, if there's any way that we can support you through this process. For those of you that are joining us in New Orleans, basically it's like a little over a week left. So we're in the finishing up phase for you all. If you are not part of the group that's going for the CS and Science Facilitation Summit, you have a little bit longer, and we'll support you through that. But we just want to make sure that you have the resources needed. So the forum is one of the best ways to get that. We monitor that regularly, and we'll try and help you with any questions. But thanks for hanging in. All right, take care.
Thanks, Paige.
Thank you.
Have a good evening.
You too. Bye, everyone.